Trees are plants that learn to be giants. They grow to phenomenal heights, stand strong, bend with the wind, and support massive branches that reach out over great distances. Recognizing that strength and usefulness, humans, like birds and beavers before us, have long used wood for construction. But while we've built things using the material that trees produce, we haven't built things using the methods that trees follow. So how do trees do what they do? To withstand forces that would break them, trees have evolved a strategic way of growing. They form their wood to compensate for those forces. As a trunk or branch grows, it will adjust the size and number of different kinds of cells, the thickness of cell walls, and the compounds within them. In hardwood trees, that results in rings being thicker on the top side of branches, stuffed with lots of stretchy cellulose fibers to accommodate the downward pull of tension. Alternatively, softwood trees build up the lower side of branches with rigid lignin to resist the crushing stress of compression. In all trees, structural support is highly adaptable, working at odd angles and curves, and built right into the material at the micro scale. Meanwhile, humans have tended to focus on supporting our structures at the macro scale, with large, straight beams and planks that concentrate intense pressure at specific points and follow relatively limited design options. Now, architects and inventors at a company called Strong by Form have devised a manufacturing process that mimics the way trees themselves shape their materials for structural performance and opens up revolutionary possibilities for the forms wood construction can take. Strong by Form starts by cutting wood into small flakes. These pieces already contain the valuable stress-bearing properties of the cellulose and lignin within them. Software then arranges the direction and distribution of flakes to bear the loads that the material needs to support. Then the system uses advanced robotics to lay down the flakes with a bit of binding resin, matching the prescribed three-dimensional pattern using minimal material to get optimal performance. And because Strong by Form's manufacturing process uses wood flakes, not sawn timber, it can make use of a diversity of tree species and a greater proportion of each tree, including smaller branches and parts with irregular forms. Strong by Form's engineered lightweight wood product reduces the amount of material needed to build structures and the cost to transport them. Yet the material is strong enough to become an alternative to highly polluting materials such as steel, aluminum, concrete, or fiber-reinforced plastics in buildings, vehicles, and furniture. By mimicking how a tree grows, Strong by Form's manufacturing process reimagines one of the longest-serving natural building materials in an exciting new way to support a more sustainable future.